Recent head-mounted displays, or HMDs, allow users to transition between real and virtual worlds. The Quest Pro often requires users to hold a controller or frequently tap on the devices, limiting the potential for hands-free interaction and hindering a truly immersive and natural virtual reality or VR experience. Prior work explored controller-based customizable lenses and virtual sliders to facilitate transitioning between multiple realities. However, researchers showed that the controller-based approaches suffer from issues regarding naturalness. In a recent study, Radu Daniel Vatavu explored index finger augmentation devices, or IFAD, where devices are integrated into the index finger for constant input availability. The author demonstrated that IFADs are easy, require minimal effort, and are socially acceptable. There has been very limited exploration of finger-based techniques in transitioning between reality, augmented reality, or AR, augmented virtuality, or AV, and virtual reality. To address this limitation, inspired by IFAD, we investigated finger-worn solutions designed to offer a fast and controller-free transitioning experience between realities. We conducted 2 user studies. For Study 1, we had a selection task. We explored a set of button-based techniques for users to switch between the multiple worlds. In the one-button technique, the user has to navigate through the worlds sequentially to reach the target world. Here the user is collecting shape information from the real world and selecting the shape information in the virtual world. In 2x1 button, one button is designated for real and AR. Another button is specified for AV and VR. To reach the VR world, the user has to click the AV VR button twice. Here, the user is selecting information in VR using 2x1 button. In 4x1 button, each button is mapped to one particular world. Here, the user is selecting information using the 4x1 button. In 2x2 button, each button is mapped to one particular world, and its design is more compact than 4x1 button. Here the user is doing the task using 2x2 button. Our study result revealed that 2x2 button was the fastest amongst all the techniques. For Study 2, we have a counting task. We evaluated continuous input techniques, that is, slider and rotary wheel, and discrete input techniques, that is, the best technique from Study 1, which is 2x2 button, and joystick. In the study, the user had to collect the shape information from the real world, count it in the real world and target world, then select the total number of shapes in both worlds. Here the user is using the 2x2 technique to perform the task. In the joystick technique, 4 directions, right, left, up, and down, were mapped to 4 different worlds. Here the user is using the joystick, moving the joystick up to switch to AR, and right to switch to the real world. With the rotary wheel, the user has to travel sequentially to go to the target world. Here the user is using the rotary wheel to collect information from AV and the real world. With the slider, users have to traverse sequentially as well. Here the user is using the slider to switch between realities. Our results of Study 2 showed that the 2x2 button technique was the fastest amongst all of the discrete and continuous inputs. Based on the 2 studies, the 2x2 button outperformed other techniques in user performance. Overall, our finger-oriented techniques not only enhance user experiences during transitions between multiple realities, but also open new avenues for natural, hand-based reality-virtuality continuum interactions.